All right, so you've got this 2024, question 4. Again, we did the first two, which I thought were pretty nice. This was the third nicest one, I kind of felt like as I was reading them. So we're given a graph of the differentiable function f. We have a horizontal tangent at -2. So again, I'm saying I have like a slope of 0 here. And it's linear from 0 to 6, or 0 to 7. Let R be the region in the second quadrant, bounded by the vertical line -6, and region R has an area of 12. So I probably would cross that off and put a 12 right in front of me. So the function g is defined here, and you just simply want these three things. So I just want g of -6. So all I'm doing is replacing my x's with a -6. So once I write it out, I notice my bounds are backwards, so I'm going to say it's the negative integral from -6 to 0. And what do I know about that answer? It's not R, but it's 12. So I'm going to say that's -12. Then I want g of 4. So again, I'm just replacing that axis with 4. So I want the area from 0 to 4, which is a lovely triangle. So I'm just going 1/2 base times height. So 1/2 4 times 2 should get me a nice area of 4. And then I want g of 6. So I want the integral from 0 to 6. So now I'm going to take what I have here, 0 to 4, and I have to take this little section and subtract it out. So this is a 2 by 1, which would make that a -1. So I have 4 plus -1, or an area of 3. Okay, so just a nice, easy 3 points, I thought. Part B says for the function g defined in part A, so you're looking at this, find all the values when the function g is a critical point. So the moment I see critical point, my brain's saying set the derivative equal to 0. So I want to find g prime of x, and I want to set it equal to 0. So that's that second fundamental theorem. When I take the derivative of an integral, I do two things to the upper bound. I substitute in the upper bound, and then I multiply by its derivative. So I'm going to end up getting f of x equals 0. Happen to have a nice graph of f of x. If I look at it, it equals 0 at x equals 4. Give a reason for your answer. So my reason is g prime of x equals 0, and we're good to go. Part C. The function h is defined by this integral. Find the values of h of 6, h prime of 6, and h double prime. So again, pretty straightforward, and just plugging this into the first x. So I want the area from -6 to 6 of f prime of t. Well, I don't have the area of f prime of t, but all I have to do is integrate. What do I get when I integrate f prime of t? F. So I'm going to get f of 6 minus f of -6, which again is super easy to find. F of 6 on the graph is -1, minus f of -6 is 0.5. Just want to stress, there's no reason to do any arithmetic in the non-calculator section. I would just leave it like that. Okay, obviously you can add that in your head if you really want to, but there's no reason to, because if you make a mistake, you lose an entire point versus like there's no 1/10 of a point. Just leave it. H prime of x. So again, I'm taking the derivative of the integral. So that's that second fundamental theorem. It's all about the upper bound. So I plug in the upper bound, and then I multiply by the derivative of the upper bound, which is 1. So h prime of 6 is equivalent to f prime of 6. Happen to have a graph of f. If I want f prime, I'm looking at its slope, and they told us that it is a linear function. So all I need is the slope of this line. And I have 2 points. I have 4, 0, and 6, -1. So that's a rise, -1, and a run 2. So that would give me a -1/2. And then if I want h double prime, I'm going to go derive h prime. So h double prime is going to become f double prime. Okay. So now think about this. F prime is linear, right? Therefore, the derivative of any linear function is always going to be 0. Okay. But again, not a bad question overall that hits that second fundamental theorem. I don't know. Like I said, I thought that was a really nice question. Is there any questions about this one or concerns? All right. Let's tackle the next one. So they get a little more fun each as we get closer to the end here. We know we're going to see some sort of differential equation. So this was question 3. Now remember, you can kind of go back and forth in these 4 questions that are non-calculator. They don't have to be answered in order. but you're referencing about 15 minutes per question. All right, so question 3 was the differential equation. So again, just looking off what they predicted, they're expecting to see another big differential equation, which wouldn't be surprising whatsoever. So the depth of the seawater at a location can be modeled by this differential equation, h of 0 equals 4. So they want you to draw on the point that passes through 0, 4. And again, it's just like driving, just like follow the flow of traffic. Just you only have to hit this point. So it clearly goes up, and then it comes back down. So that was 1 point. Again, I think everybody in the country is going to get that. Just follow the flow of traffic. Part B. It says H has a critical point. So to find a critical point, you're setting your derivative equal to 0. Okay? And again, this is my derivative up here. I'm setting that function equal to 0. So 1/2 h minus 1 cosine of t over 2 has to equal 0. Which seemed a little intimidating at first, but it's basically something times something. So it's already 2 factors. It's this times this. So I'm kind of just teeing up each side. Okay, now we're solving for the time that we have a critical point. So there's no time over here, so I don't even have to worry about this side. There's no t in there. I do have to solve this side when the cosine of t over 2 equals 0. So we've done this many times throughout the course. It's been on a lot of spirals. The easiest thing to do is to ignore what's inside here, okay, and think, when does cosine equal 0? So picture your cosine curve. Cosine equals 0 at pi over 2 and at 3 pi over 2. So at pi over 2 and at 3 pi over 2. And then I'm just setting, because it wasn't really cosine, it was cosine of t over 2, I'm going to set t over 2 equal to each of those to solve. So I ignore what's in the middle, because I can solve cosine equals 0 in my head easily. Once I figure those values out, I set that inside equal to that, and then I just cross multiply. So 2t equals 2 pi, therefore t has to equal pi, 2t equals 6 pi, t has to equal 3 pi. Now it does say in the interval 0 to 5, and since pi is 3.14 times 3, that falls outside of it. So my only critical point would be at t equals pi. And then it says determine if that is a min or a max based off that. So I'm going to make a quick sign chart at pi from 0 to 5. And I'm plugging them back into the derivative. Now, I just use this visual representation of the derivative to answer that question, because pi is approximately 3.14, and if I look at the curve, I can visually see I have a what there? A max, right? These slopes are all positive, right? Up until 3.14 pi, all the slopes are positive, and then after pi, all the slopes are negative. So I just use literally the flow of traffic there to find my justification. So I would say I have a max at x equals pi, dh dt changes from a positive to a negative. Obviously, I would write a sentence there, but dh dt changed from a positive to a negative. That was 2. Yeah. All right, so the big one. We've got to make sure we can solve these differential equations. So the idea is that we separate and integrate. Okay. So I want h's on one side, t's on the other. So I'm going to multiply my dt. You can think of it as a cross multiply or whatever. I'm going to multiply my dt over. So that's gone. So I need my t function to stay. I need my h function to go over. Now, you could take the 1/2 with the h, but then you have a fraction in the denominator, which is a little ugly, so I'm probably going to leave the 1/2. So I'm going to say I get dh over h minus 1 equals 1/2 cosine of t over 2 dt. And again, I chose to leave my 1/2. You certainly didn't have to, except you'd have a complex fraction then, but to me that was easier. You can do whatever works for you. Okay, so that's 1 out of the 6 points to separate correctly. You have to get that to earn any points after that. Then we're going to slap an integral on each side. Okay? If I try to rewrite this as u to the 1, I'm going to get u to the 0 over 0, so I know I need an ln at some point. So I'm going to say my u is h minus 1. My du is equal to dh. So I'm going to get the integral of du over u. Okay, on this side, I'm going to pull out my 1/2. And I have my cosine, and my u is my inner function. My u is, I'm going to call it 1/2 t, or t over 2, doesn't matter. So my du is equal to 1/2 dt. Therefore, I'm going to get 2 du equals dt when I multiply both sides by 2. So again, my inner function is my u, took its derivative, and I'm going to substitute that back in. So I'm going to get u, and then I'm going to get 2 du. So my 1/2 and 2 should cancel out, and all I'm integrating then is the cosine of u. This left side, anytime I have a du over u, becomes the ln of the absolute value of h minus 1. And on this side, I'm saying, who do I take the derivative of to get cosine? Definitely a positive sine. So I'm going to say it's the sine, and my u was 1/2 t plus c. Okay, and then I'm going to use that condition, what was it, 0,4, to get that c value. So I get 4 minus 1 is 3 equals the sine of 0 plus c. The sine of 0 is 0, so c equals the ln of 3. So I've got the ln of h minus 1 equals the sine of 1/2 t plus the ln of 3. My goal is to get h by itself, so I now have to use an e to get rid of that h. You can only put one e on each side, so I'm going to wrap up that whole exponent. Okay, so that only eliminates the one it's touching here, so I have h minus 1 equals. What I want to do is that decomposition. If I see addition in my exponent, that meant I was multiplying two things. So I'm going to say this is e to the sine of 1/2 t times e to the ln of 3. But I can only start with one e on each side, and then I'll use decomposition. This is now going to become a 3, so I have 3e to the sine of 1/2 t, and then I'll just add over the 1. Lastly, I want to make sure that this was supposed to be a positive versus a negative, so I just want to plug in that 0 and make sure I get a 4. If I plug in 0, so again, I'm just always going to test to see that this should be positive or negative, because this absolute value up here could mean it could be either. I'm going to get the sine of 0, which is 1. 3 plus 1 is 4, so I do want the positive version of that. Okay. So I'm pretty confident. I mean, again, like we're all predicting, but I'm pretty confident, you know, a differential equation is a pretty big question that they're going to ask. I would expect that to be one of those, or one of the 6 questions. So this is on video. If you need to go back and watch it, you can Google, you just go back and look at any free response that has a differential equation and try them again if that was, you know, something you were stuck on. All right, got a few minutes left, so just flip over to the back, wherever you got some blank space. And wanted to pull up a question or two that stood out from the test the other day. Definitely one on here that stood out. We'll tackle this one. Draw yourself this triangle here. I wouldn't be surprised. My guess is the related rates on here is either going to be an angle question or a shadow question. And I know people ask for related rates, so I'll definitely hit some more on Friday. So we've got a person that stands 30 feet from point P and watches the balloon rise vertically from the point, as shown in the figure above. The balloon is rising at a constant rate of 2 feet per second. So the first thing I do is I just assign some labels to this picture. I'm going to redraw this so I don't draw this picture. So I'm first going to call it like A, B, and C. Like I try not to use something I can't read, but I'm going to go A, B, C. It says the balloon is rising at a rate of 2 feet per second. So who are they giving us? dAdt. dA dt is 2. It's rising at 2 feet per second. What is the rate of change in radians per second of the angle? So we are looking for d theta dt when the balloon is 40 feet above point P. So that would be side A. Okay, so this is definitely a trig problem because we're looking for an angle. So when we do trig, you want to say, what two sides do I know the most information about? So obviously, you know the height and the rate of this side. We know the length of this side. Do we know the rate of either one of these? I think we do. 30 would be 0 because that person is just standing still. Yeah, we actually do know this rate. This isn't going to change because this person is just standing here. So I know dB dt is 0, and that's one of the keys. You want to pick something where you know two things about them. So I know something, if this is my angle, about the opposite and the adjacent. So which trig function would use opposite and adjacent? Tangent. So I'm going to start with just tangent of theta. Tangent of theta is my opposite over adjacent, so that's going to be A over B. Okay, so now you want to say, is one of those terms going to be constant? Is one of them not going to change in length? And if it is, then you can plug that in first. Well, we just said this guy is always going to be 30 feet from this point. So because that's a constant, I can plug that in first. My B is 30. So now I just want to take this derivative. The derivative of tangent is secant squared theta times the derivative of the inside. That would be my d theta dt. So chain rule, derivative of the outside, keep the inside because it's a related rates. Now a over 30 can really be written as 1/30th times a. So that derivative is just 1/30th times d a dt. Okay, so the only thing I shouldn't know is d theta dt. I should be able to figure out everything else. Let's start with the easy one. dA dt they told us was 2, so I can plug that in. I'm looking for d theta dt. I've got to figure out secant of theta. So just think, secant comes from which of your main trig functions? Not derivative, but sine, cosine, or tangent. Like which one is it a reciprocal of? Cosine. So I want to take the cosine of this angle and then flip it. So if this is my angle, the cosine would be A over H. So now I need this side, which is actually, it's almost always a triple. Hopefully you know your triples, 3, 4, 5. So I should know that side's 50. If I didn't, I'd use Pythagorean theorem. So my cosine is 30 over 50. Therefore my secant is 50 over 30. So I'm going to say it's 50 over 30 squared. Now I'm not actually going to square all that because what can happen with my zeros here? They can just divide out to 5/3. So I really have 25/9 d theta dt equals 1/30th times 2. Okay, then again, to get this by itself, I'm going to multiply by the reciprocal. I'm going to go 9 over 25, 9 over 25. And then I never like multiply all this. I kind of like simplify as I go through. Like 3 goes into 9 3 times, 3 goes into 30 10 times. 2 goes into 2 once, and into 10 5 times. Okay, that's a lot easier than me trying to multiply and then reduce that fraction. So on top, I think I'm just left with 3. And on the bottom, I have 5 25s, which is 125. And again, I can hit more related rates Friday, but I definitely wouldn't be surprised to see either a shadow or an angle problem again. And again, you can reference back to this question in the video that I post for you. Trying to think of what else stood out. There was one question early on. Oh, you guys still don't like this question. I don't know why. 14. particle moves in a straight line so that its acceleration is 12. So let's jot down 12t, bless you. Acceleration is 12t. At t equals 0, the velocity is 2, and the position is 5. Okay, and you have to get to position. So it's more, I can't put bounds on this thing because these aren't even about the same function. This is about velocity and this is about position. It wouldn't make sense for me to put bounds on it. They don't even deal with the same function. I just have to keep integrating. So I have to integrate both sides. So who do I get when I integrate acceleration? Velocity. And then this would be 12t squared over 2 plus c. So I get velocity equals 6t squared plus c. And then I want to solve for that c value with one of those initial conditions. So I know at t equals 0, the velocity is 2. So I would plug in my 2 and my 0 to solve for c. So I think c equals 2. So I would get 6t squared plus 2. And then you just do it, you repeat the process. Okay, and I feel like this has been a really common question. So again, I'm expecting that you'd see one of these in your multiple choice. So I integrate again. So if I integrate velocity, I get position. Bless you. So I get 6t cubed over 3 plus 2t plus c. And now I'm using the 0 and 5 because this is about position. So that's 0 plus c. So I think I get c equals 5. So my position would be that 2t cubed plus 2t plus 5. But I would say that's a fairly common question that we should be able to get in that section. All right, so you've got, I think this is the last homework packet, so due Friday. I think it hits differential equations, which seems to be something we need to work on just a tad. So you've got that due Friday, and then the last spiral if you're lingering on to that. And I think we're good, the no bells day, so I think we're right at 9:05 there.